All right, so what we're looking at, guys, on a question like number 1 is that they're providing you side, side, side. So what we need to do is come up with a law of cosines argument to find missing angle measurement. Okay, and I want to talk about this question because I think a lot of people are approaching it kind of in that monkey see, monkey do process, or the idea of not thinking about what you're doing and its consequences. Yeah. What we're looking at here, guys, with this one, side, 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 and what I want you to understand is that they asked for angle A, B, and C. The most work that you do here should be solving for angle A. Okay? Once you find angle A, there's an easier approach to find B than using the law of cosines again. There's an easier approach to find C than using the law of cosines. And that's what I hopefully can relay to you as we work through these problems. Once you start finding one value, it opens up more doors, more avenues for you to continue the problem and maybe using easier approaches. So, that being said, if I look at angle A, that's what I'm trying to solve for. It's going to be paired up with 4, right? So we say 4 squared is equal to, we'll have a bunch of garbage in the middle, but there'll be cosine A at the end, right? Okay. Now, what goes in these other spots?
5 and 8.
Okay, so I go 5 squared plus 8 squared minus, then the 2 is always a 2, right? And then I just always put them in the same order, 5 and 8 again, right? Okay. Now, at this stage, guys, a lot of people are doing this, which is perfectly fine. They're saying, well, this turns into 16. This turns into 25. This is 64. Okay, does everybody agree with that? Now, this here is going to be 80, isn't it? Minus 80. And we've got cosine of A. And at this stage, I'm getting a lot of people to take the 25, add to the 64, subtract 80.
You can't.
Why not?
Because it's part of the cosine of that.
Okay, so these two things are that's a product. You cannot start, if I had something like 25 plus 64 minus 2 times 3, you don't do that math there and then multiply by 3, right? Okay, you're going to multiply the 2 and the 3 because of order of operations and then run through the addition. So that's what we got to pay attention to here. I think what makes maybe even a little bit more sense, what we've been doing in other classes today, say, okay, that's unknown, right? A is what we're looking for. That's kind of our variable, but it's stuck inside cosine, so that whole thing is unknown. Let's do this. This might make sense to us. Let cosine of A equal x, and now let's make a substitution. What's 25 plus 64? 89. Minus then 80. Now I just let cosine of A end up being x. So that's something like that. Does that make sense? This blue statement and this red statement are ultimately the same thing. How would you solve for x in this red statement? You subtract the 89, right? Okay. So in this blue one, these two things make the 89, right? So can I subtract those from both sides? Okay. What's 16 minus 89? Do it this way. What's 89 minus 16? 73. So 16 minus 89 is the reverse order. So it's negative 73.
What is that thing called?
Huh? That? Negative sign?
I don't know if we have like a weird name for it. Like how the blue one is called silver.
All right. Equals then negative 80x, right? What would you divide both sides by now? Negative 80. Okay, so the negative 73 divided by negative 80 is a positive 73 over 80. And that equals x, right? But what was x? What did we say x was up here? Cosine x. Let's put that back in. And now I got that equation, right?
Yeah.
How do I solve for x? Okay, good. So I'm going to go cosine inverse, or arc cosine. Okay, so that was why you're messing it up?
Yeah.
And that's our answer for A, right? Okay. Now, if we're going along the path of solving this, leaving it as, cosine of A in there. Okay, again, you can condense this stuff, but you don't have to. But if I subtract over the 25 and 64, it's going to be negative 73 minus 80 cosine A equals negative 80 cosine A. So then I would divide both sides by negative 80, right? We get 73 divided by 80 equals cosine A. I used the substitution that cosine A is equal to x, solve for x, and then resubstitute. You don't have to do that if you can, in your mind, make the link between the fact that cosine A is just a variable, we treat it as all other variables. Okay? So, when we do that, we go, let me get a Desmos up here. And I've had many of people doing this today. They're typing everything in right, getting the wrong answer, and what's the reason? Why they type everything in wrong with the wrong answer? Yeah. So arc cosine, what would we say, 73 over 80? So that's in radians. So we're going to put that in degrees, and we get 24.15. Yeah, so when you're in radians, guys, based on our answers are always going to be between, if I'm in radians, my answer is always going to be between 0 and 1.57, okay? Because 90 degrees is pi over 2, 3.14 divided by 2, which is about 1.57. And that's when we're working with these triangles, we're only ever going to get an answer between 0 and 90. Okay? Actually, let me rephrase. We could, I guess the ones we've seen so far, we could be working without two triangles. We might get a number between 0 and 3.14. Yeah. But still, we're probably not going to be dealing with angles that are that small. So that when this value becomes very, very small here, okay, when you see that number is very, very small, chances are you are in the wrong mode, and now it's a little bit better. Okay. So 24 point, let's go, I'm going to round up to 24.15. All right, what I've been telling the other classes, guys, let's think about this. Because I think this is going to be useful for you when you get into more advanced courses, being able to do this math. If I evaluate this, I have to know what 4 squared is, and I have to do that work. And I have to know what 5 squared is, and do that work. 8 squared, do that work. Now, those aren't numbers that we can't do. But what do we end up doing? We end up adding those together and then subtracting them both, right? Yep. Well, if I add those together, I got, what was that number, 89? Mm-hmm. If I take 89 and subtract it from 16, is that the same thing as taking 16 and subtracting 25, and then following that up by subtracting by 64? Yeah, so I can chunk that up. So why don't I just write this? 4 squared minus 5 squared minus 8 squared. I didn't even have to do any evaluation. I'm just telling everybody that I'm going to subtract that 89 from the 16. And then, if I do that, I would be left with that on the right-hand side, correct? What is that number right there for cosine A? It's a coefficient. It was the 80, right? And we divided that by both sides, right? And then we cosine inversed. And in my opinion, obviously if you understand your algebra a little bit better, that is easier to generate what A is rather than evaluating all those individual parts, multiplying together, adding like terms, moving everything to one side, that kind of thing. We can do all that stuff without evaluating, okay? That's all our algebra without evaluating. And if I type that in, bear with me. Can I? Yeah. Just give me a minute. All right, so if I go, I need, because there's subtraction in that numerator, I need to make sure I put that in parentheses, and that's why maybe if you're using the TI-8384, maybe you're getting the wrong answer. We need those parentheses, because I want the calculator to do that evaluation, like we were doing on paper the last go-around. I want the calculator to do that calculation and get that, what was that number? We had 73. I want to get that 73 calculated first. I then want the calculator to, and it will do this because of it only being multiplication down here, it will make that 40, or sorry, negative 80, I guess. So I have negative 73 over negative 80, and then it will finally divide those, and then run that quotient through the cosine inverse, and what do you notice? Two answers are the same, right? Okay, so this must mean that that is the 73, and that is the 80. Okay, obviously the signs are canceling out, but is that all right, everybody? Now, if I do on the TI-8384, and this is where people are getting themselves in a little bit of hot water with these questions because we are not paying attention to the order of operations. If I just type in second cosine of, let's say, 4 squared minus 5 squared minus 8 squared, divide by negative 2 times 5 times 8. That is what most people are going, when they get this wrong, that is what they're usually doing. Make sure I'm in degree mode. And I just want to prove to you, I'm going to hit enter and see what the answer looks like here. All right, and I get that error. Okay? All through what that means is the cosine you're only allowed, think about what the cosine is. Cosine is opposite over hypotenuse, right? Yeah. So if the hypotenuse is always the longest side in a right triangle, correct? Yeah. So O divided by H is always going to be a number between 0 and 1, right? Now with a little bit of our trigonometry, we can actually have numbers between negative 1 and 1. So they can be negative, just because of how cosine works with trig. Basically, what this is telling us, that domain error, is that I'm looking at a value outside of that. Okay, I've got an issue here. Okay. So what we need to do here, and I'm going to talk about why this is happening. What your calculator is doing here, if we look at this order of operations, it's running through. It's making, because of PEMDAS, it's making that 16, that 25, that 64. Right? Does that make sense? Has to do those first. So let's write down kind of what it's doing. 16. I can't write on top of that for some reason. Let's go. So it's writing down 16 minus 25 minus 64 divided by negative 2 times 5 times 8. That's what my calculator is storing after it does one evaluation process. It is then going to go through here, and what's it supposed to do next? It's going to do that. Good. So it's going to go 16 minus 25 divided by, so then minus that divided actually turns into a positive, right? 64 divided by 2 is 32 times 5 times 8, right? Yeah. Now what's it going to do? Yeah, it's going to go 32 times 5 times 8, right? It's going to evaluate that. And it's going to take 16 minus 25 plus that number, which is in 100, okay? Add them together and then run that through the cosine. That's not what we want, okay? Don't we want this 8 to be subtracted from the 16, essentially? It's 8 squared subtracted from the 16. So what do I need to insert? I need to tell my calculator that my numerator needs to be evaluated first. Okay? And then, so I put a parenthesis there. I'm a genius.
No, I always just replace number that has
I'll show you. And then, so I need my numerator to be evaluated first, and I'll store that 73, that negative 73. I then need to tell my calculator, evaluate the denominator second, store that as negative 80, and now that is one object, order of operations saying we're dividing all of this stuff by all of that stuff. Hit enter, and that's where I get my 24 degrees. Okay? Now, how do I do, so I want to,
Yeah, I'm not sure if you can tell, but I'm really bad at technology. So.
if I want to add something in, okay, like for instance, maybe I wanted a 1 right here in front of that 5, right? What Alex is saying is that he usually just puts a 1 there and it deletes everything, right? And it just retypes what's at the end. Well, that kind of sucks if the 4 is what I need to change, right? Because now I got to type everything else. And let's say I want to put a 1 in front of that 4. What you do, wherever you want to insert something, you highlight the character that is after the position that you want to insert. So I want to highlight the 4 because I want to put a 1 in front of it. And then I hit the second insert key, and you see how your cursor now is not a block anymore. It's that underline. And now I can type in anything I want to. And as long as it's being a cursor that's an underline, I can keep typing in whatever I need to before that 4.
All right, thanks.
Okay, so that's your insert key. Kind of operates the same way on your keyboard if you've ever used that, but it's kind of screwy on Word. It's weird. Okay, so that's how we find that angle. That was obviously a long discussion for finding that angle. Hopefully we feel comfortable doing that. Okay, let's find angle B. I want to find B. Okay, now if you're being robotic and you're not paying attention to what you've already found and what you're supposed to be doing after you found angle A, you might be a person that does this. 5 squared is equal to 4 squared plus 8 squared minus 2 times 4 times 8 times cosine of B.
Why would you do that?
Why would I do that? Because,
Law of science.
okay, so the law of science is going to be quicker. But I could do this, right? Now let's talk about these two versions of answers here. Because when I do that, I'll let you kind of finish the algebra there. Okay, we'd be looking at, I wish my screen was bigger. We'd be looking at the arc cosine of 5 squared minus 4 squared minus 8 squared divided by negative 2 times 4 times 8, right? And I would get that. Does that make sense? Now, look at all these numbers up here. Any rounding taking place there?
No.
No. So this kind of answer is what?
Legit.
It's legit. It's an exact answer out to that 8 right there. Okay? Now, let's do this. You said, why would I do that? Why wouldn't I just use the law of sines? I'm going to use the law of sines. Don't those two things pair up?
Yep.
So I'll say sine of 2415 over 4 is equal to sine of what? B over 5. Cross multiply. 5 sine of 2415 is equal to 4 sine of B, right? Next step is to divide by 4. Next step will be to sine inverse, right? That's going to give me my B out. So let's type that in. So arc sine of 5 sine 24.15 divided by 4. Is that number and that number pretty close to being the same? Okay, why are they different? Because of 24.15, right? That was a rounded value, it's a rounded angle measurement. Okay, so it creates a problem. Now, here's a question for you. Can I make it the same? I don't talk about this with any other classes today, but can I make it the same? This 24.15 number is this, isn't it? It's actually all of this. So let's see here. Let's see if I can copy that. And instead of putting 24.15 there, let's put that there. Okay, now that's ugly, right? That's ugly. Okay, but that is right there. That is that angle, right? That's angle A. All right. Is it now giving me the exact same answer that arc cosine gave me?
Yeah.
Okay. So those are options. Obviously, with this question, I think they're trying to get you to use the law of sines, because is the law of sines ultimately quicker? Yeah, okay. But we have to understand that there is a degree of error when I do use the law of sines. Okay? Now, if I take that number and I take that number, okay, so what am I going to do with that 54.9 number in order to solve for angle C?
You're going to add it to the other angle.
Well, I already added. So this is the first angle we found.
Oh, yeah,
That's the second one we use for law of sines. So I'm going to go 180 minus that, right? So those are my three angles: 30.7577, 24.148, and 125.096. And the idea is, obviously, when they start you off with three unknown angles, when you use the law of cosines, that is the most, I think, rigorous algebra that we have to do in this problem. And once we find that value, that first value using the law of cosines, it opens the door to using the law of sines. Okay? And then once I find that second angle using the law of sines, my hopes are that we do not try to use the law of sines again or law of cosines again. We have a alternative option, which is much quicker, the triangle angle sum theorem. Okay? So and that's the thing about thinking about what you're doing and all of your kind of tools that you're allowed to use to solve triangles. Okay? I would really hate to see this question on the test tomorrow and ask you for all three angles, and somebody spends time, let's say it takes 3 minutes to do the law of cosines. Well, if I have to do the law of cosines 3 times, that's a 9-minute problem, right? But if it takes me 3 minutes to do the law of cosines, maybe it takes me a minute to do the law of sines, and it should take maybe 10 seconds to do the triangle angle sum theorem. Maybe somebody that was traditionally doing that question in 9 minutes, now they can do it in maybe 4 minutes. Okay, it cuts time in half, right? Think about the ACT. I know you guys has anybody taken the ACT in here yet? Okay, so ACT math section is 60 questions in 60 minutes. Okay, do I want to spend 9 minutes on one question? Oh, okay. Then I'm losing time on the other one. So I want to be able to bank as much time as I possibly can, because as that test progresses, you're going to do the first 20 questions, all right, I'm going to ace the ACT in the math version. And then you get to the last 20 questions, you say, I failed this thing. Okay? Because you, at the stage of a sophomore or a freshman, you just haven't seen enough math to be able to address the last 20 questions. But those last 20 questions, if you approach those without kind of accruing the knowledge of year 1, year 2, year 3, and understanding the efficiency process and the efficiency concept in mathematics, you will still struggle on those last 20 questions. They're time consuming. Okay? But there are ways to approach them they're going to save you time. And that's kind of what I hope you guys experience and see throughout this course. Okay? If it was unlimited time, kind of maybe like homework is, maybe law of cosines is perfectly fine every single time we do it. Obviously, there's going to be things that are timed. Somebody said I'm not good at technology. Okay, I understand that, but that's, in this day and age, that's not acceptable. You're going to be unemployed if you assume that I'm not good at technology, so I'm not going to get better at it, right?
No, I'm just talking about
like school stuff. It doesn't matter.
No, that's not what I like. I don't know how to code a computer. Send out emails and
I didn't either, but I mean, you eventually you'll get there.
I know how to use the actual.
Yeah, you have trouble with emails. I know that. All right. I think in the last classes, there haven't been many questions beyond that one. Okay. The other versions of, I don't know why my homework's not showing up. The other versions of the law of cosine questions were pretty much just, here's a side, an angle, and a side, plug it in, and let your calculator do all the work, right? One thing I've seen people doing when they're trying to look for a side using left cosine, they forget to take the square root, and they forget to be in degrees. Those are a lot of the issues that I'm coming across the last couple of days. Is not procedural stuff, or I guess let me rephrase it. It's not mathematical stuff. It's more procedural in regards to changing the calculator to the right mode, taking square roots when you're supposed to, that kind of thing. Okay. Do you guys have any more questions over left cosine? Okay, what questions you got on the review then? What question is it? Question 41?
I can go over some radical ones. I've done, I think, all of them all day, and I still don't know. Radicals.
All right, so this is a good question to ask in preparation for tomorrow's test. Seeing how it's on there.
You think one without the same number?
Huh?
Like that 2 and that 2?
Oh, yeah, mine was the same.
Well, that shouldn't matter.
So we know where you're getting the 2 from.
Okay. All right. Do you know anything about that overall triangle? Yeah, how do you know that right off the bat? So you know what assuming does?
They get you killed.
Alright, so you cannot make an assumption about what these angles are, okay? But you do know something about that, right? What's that mean?
That means it's 90 degrees.
Okay, so that means triangle number 1 is a,
Right triangle.
and triangle number 2 is a,
Right triangle.
and in right triangles, and you have 2 side lengths, you always know how to find the third using. All right, so can I say that the Pythagorean theorem says a leg squared plus the other leg squared. So I don't know this leg up there, so let's B's maybe not. Let's call that. Okay, Z. Z squared should equal what squared? 3 radical 5. Now, if you're a person that doesn't know how to square radicals, that might be an issue. However, you will have your calculator. And however, that can still be an issue. Because if you're going to use your calculator to square this, you need to understand order of operations and put a parenthesis around the 3 in essentially this 5 here. So you need to set a parenthesis on your calculator. But what's 6 squared? Okay. Plus then Z squared. Now, does anybody know how to do that? How'd you get?
Yeah, well, it clears out that thing. That's the big.
Okay, so the 2 clears out the radical.
Yeah, then you just won't
What about the 3?
Yeah, wouldn't it be 9 times 5?
9. It should be 9 times 5, which is.
I did exactly what you told me.
45. Okay, so 3 radical 5 squared. Think about what that means. It means 3 radical 5 times 3 radical 5, right? Think about what that means. That means 3 times 3, right? We multiply the numbers on the outside, and then we multiply the numbers on the inside. So it's something like that. Does that make sense? We multiply the numbers on the outside, they stay on the outside. We multiply the numbers on the inside, they stay on the inside. What's 3 times 3? What's another way of writing 3 times 3? I can write it as 9, but I can rewrite it as 3 squared. Can I rewrite radical 5 times 5 as kind of that? And actually, the algebraic rule, because they're the same, is really doing it this way. So it gives me square root of 25, which is just 5. So this gives me 9 times 5. So the reason I'm doing this is because I'm trying to show you the rule of when you have a product and you're trying to square a product, you actually square each factor of the product and then multiply it together. The rule you learned last year would have been something, it would have looked like this. It would have looked like this, like A to the M b to the n. Now, if you didn't remember this from last year, I taught you this year. Okay, so let's say I put r up here. Okay, if you're trying to do, so this would be something like 3 to the first times radical 5 to the first, all squared. All you do is you take a, and then you take m times r, and then you go b, and it's n times r. And that becomes your exponent. So what are these exponents here? That's a 1. And this radical 5 has an exponent of 1. So 2 times the 1 gives me 3 squared, which is that. And then the radical 5 to the first gives me radical 5 to the second, because I take the 1 and the 2 and multiply them. So radical 5 squared is just 5. Okay. Now, if I were to use my calculator, so I know I should be looking for 45. If I were to take 3 radical 5 3 radical 5, and I square that like this, that's going to give you 15, because the order of operations says that the exponent goes only to the thing that is directly behind. We need to be directly behind all of that. We need to do something like that. Does that make sense? Now if I do that, I get my 45. Okay. Okay, so let's continue with the problem, and then we'll address the other issue. So z squared ends up being, what's 45 minus 36? 9. So z then is 3. So that is this side here, right? Okay, so now if I've got that side, what kind of triangle is that on the right? A right triangle, meaning I could use Pythagorean theorem a second time. Okay. Okay, so what's 3 squared? 9. Plus then what's 8 squared? Oh, sorry, what's 18 squared? My fault. 324. That should equal x squared, right? So you add those together, you do get 333 is equal to x squared. Now we'll take square root, and it gives me x. Okay. Now 333 is 3 times 11 times 2 times 5, I believe. None of those have partners, right? Okay, so radical 333, I believe, simplified.
I got 3 radical 37.
Is it?
I put 9 in there. I don't know what I did.
So let's see. So 333 is going to break down to 3 and 111, right? 111 divided by anything? No.
I put 9 in there and it gave me back 37. And then
Well, that means that 111 would be divisible by 3. I think that does. Yep. So this is 3 and 37. So now those two pair up. Gives me 3 root 37 as an answer. Oh, no, the 37 is a prime number, isn't it? Okay.
I got the radical thing right.
Good. So that's kind of what we're looking for on this. The ask you to type it as a flat radical. Okay. You're going to see that question tomorrow. Okay. It's just a Pythagorean theorem 2 times.
Are we going to need those? Because those are I don't like those. I taught you how to do that. I still don't know. They're not hard.
Oh, wait.
Wait, are both the X's? Can't teach her. I want to teach her how to do that. Well, it didn't work the first time.
So you gave up?
Yeah.
So what are we struggling on? What want to talk about? You said you're struggling on something.
Radical.
Radicals?
Yeah. I forget what number it was. I did do the radical. Factoring and radical.
It's just dividing.
I don't know. I don't. Out of my brain. I don't know. I just don't know how. I don't know the rules of it, so I just. When everyone looks.
Why don't you know the rules of it? Huh?
I think attention last year.
You don't know anything from last year. Okay, I can accept that. But what I can't accept is the endless amount of times I've told you that if you don't know how to do radicals, if you go down here, click on that, so that there's really no excuse for not knowing how to do these, because you can teach yourself. Obviously, you have somebody through these videos teach you, but if I don't know how to simplify radicals, by golly, there's 8 videos here that do it.
This is my favorite chapter I've ever done. I would watch those.
So that's huh?
Being honest, I would put those on YouTube and on my TV and get on my phone. I'm just saying.
So here's the thing. Is that my fault or your fault? So it's my fault that you don't want to do it, so then I have to teach you again in class after I've taught you multiple times. Because you fail to do the legwork on your own.
I do a lot of that. See, this chapter is so easy. Like, one of the easiest ones we don't.
Do we understand? Do we understand that? Like you're gonna get to a point, like, because I'm of the nature that I'm gonna help. Like, I shouldn't, but I'm going to. But you're gonna get to a point where you get a teacher that says, "Well, you haven't done the things that you need to do, so I'm not helping you."
I did. I watched it.
No, you didn't. You're such a liar.
Yeah, that one right there is Khan Academy.
No, it's not. This one? That one? Yeah, because it's got a black screen. That's all he does. It's actually not Khan Academy. It's that guy right there. But there are guys. I mean, look at these. Look at the pictures here. All right. Is that exactly what we've been doing every time that we do one of these examples? They break it down. I mean, there's only so many ways you can do these things, and it's not like I've made the math up to where what I do is different than anybody else does. Okay. So they're going to walk you through the steps to how to do this. But you have to have the initiative to go and do it, right? You can't just be accepting of, oh, I don't know, so I don't know.
That one right there, that one, like that right there, I would get all the way down to that and have no clue what to do after. You just pair them up.
They show you what to do.
You literally pair them up. You pair up the 2 2s, you pair up the 2 3s. You are not the teacher. Yeah, so it'd be 6. Do it.
Watch those videos. It's going to help you.
This is so easy. It's not that hard for